So starting with Tia's method, what do I know? What did we talk about yesterday? What do I know about this shape right here, this triangle? What do I know? Shreyas?
Every triangle is 180 no matter what.
I know every triangle is 180 degrees because what did we do yesterday?
We did that thing where we cut the and then we like connected them and then it was like 180.
We showed that the corners of the triangle would make a straight angle, which is 180 degrees. Okay, so we know all the angles, Alex, spit out your gum, of the triangle equal 180 degrees. Okay, now, what did she do in this next step? So this right here, this is what we call a regular pentagon. Can anyone tell me the difference between a regular polygon and an irregular polygon? Sophia?
Regular polygons were all like sides of the same.
Okay.
Irregular is when they're the same.
Okay, the only thing I'm going to correct on that is regular is, she was right, she said all sides are the same, but all angles are also the same in a regular polygon. Okay, whereas an irregular polygon, sides and angles are different, or can be different. So, if you think about it, a square would be a regular polygon. What would a rectangle be?
Irregular.
Why would it be irregular? Noah?
It's not the ends like
The sides are different. The angles are still the same, but the sides are different. So a rectangular would be an irregular polygon. So what I have right here is I have a regular pentagon. Okay, and what did Tia do in this regular pentagon? Shreyas, what'd she do?
Split it up into triangle.
She split it up into triangles. So she drew from one vertex. She drew from one vertex. She did that. Okay, so now how many triangles does she have? Lance, how many does she have? She has 3. And based on what we just said, how many degrees are in a triangle?
180.
180. So what should I be able to do here? Jonathan?
Multiply 180 by 3.
I should be able to say 180 times 3 is 540. Okay? So in this pentagon, I should have 540 degrees. Now, let's talk about what I'm measuring in this pentagon. Okay? Let's talk about what I'm measuring in this pentagon. Because when I do that, if you watch my highlighter here, hopefully it's dark enough. Let me make it a little darker. Maybe. It's just an app. It's called Doceri. Okay, so I'm measuring this angle. Oh, come on, highlight. It's not letting me.
We're not that weird. I think that's a child.
It's mad at me.
No, it's always.
Doceri desktop issue. Reconnect.
Wait, I got
Reconnect. There we go. Okay. So I'm measuring this angle, and 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 this angle. Okay? Now, that's okay, because how many angles am I actually measuring right here?
5.
I'm measuring 3 different angles right here, but really, it's all adding up to be this big angle, correct? Okay, so I've got all of my major angles accounted for. I've got all my major angles accounted for. Okay? We got that? Let's look at the next one, the quadrilateral. I've got how many triangles? 2. What's 180 times 2? Which, does that go with what we determined yesterday?
Yes.
Yes, we determined that all quadrilaterals have 360 degrees. Good. So now I have this next one, and this is an irregular figure. What is this? It's an irregular hexagon, because not all the sides are the same. I have 1, 2, 3, 4 triangles. 4 triangles. So 180 times 4 is what?
720.
720. Right? So, we good so far?
Yes.
Okay, so let's now move. If I draw an angle now on these new ones, okay, does it work the same? So I'm going to draw, that's not going to be pretty. There we go. 1 there, 1 there. How many triangles do I have? 3. So I would still have an angle measurement of 540. So even for this irregular pentagon, I would have 540. If I drew one here, I still have 2. So what would I have? 360. Okay, if I drew one here, this has got quite a few. They're not all connecting exactly, sorry. Okay, how many? I have 6 here. What would that equal? 1,080. Okay, so would it work for any polygon?
Yes.
Yes, it absolutely would work for any polygon. So let's go now and look at Cody's method. Okay, is it the middle though? No, he just picked a point, right? And then what did he do from that point, Noah?
So he will multiply it by 180 in this.
Hold on, we're not there yet. I'm asking just what he did.
Oh.
What did he do? He found a point.
Oh.
Who's Siri is talking? Turn your Siri off, please. Okay, Nolan, so he picked a point, Nolan, and what happened?
He connected it to every vertex.
He connected a point to every vertex. So he came here, and he said, I'm going to pick this point, and I'm going to connect to every vertex. And so how many triangles do I have?
3.
I have 1, 2, 3 triangles. Okay, so what is 180 times 3? 540. Now, some of you notice that this is a problem. And why is this a problem? Why is this a problem, Manali? Every triangle can only have a total of 180 degrees, correct?
Yes, ma'am.
So I can't have 540 degrees in this triangle. It's not just some weird triangle that has 540 degrees. So let's talk about what we're actually finding here. We're finding this angle measurement, and this angle measurement, and this angle measurement, and this one, 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 and this one. Okay? Now, really, what angle measurements do I need when I find a triangle? What do I need? I just need this measurement out here. I don't need that in there. Okay? But I'm finding that when I do 180 times 3 because it doesn't take into account that I have this middle space I don't need. Okay? So what can we do to get rid of that? Matt? Why 360?
Because the dot means like 360 degrees.
Not the dot. Shreyas?
Because it's circle the angle right there where it is, where all the lines connect,
Okay.
and that makes 360.
Okay. The angle sum around any point, and that keyword is around. Okay. Around tells you that it makes a circle is 360 degrees. So this equals 360 degrees. And I'm going to subtract that from 540, and I would get 180 degrees.
Whoa. So they're both right.
They are both right. Yep, both methods work. Jonathan.
I get the point.
Ha. Ba-dum-bump-ching. Okay. So let's try it on this one. Let's try it on this one. So how many triangles do I have?
5.
I have 5, so I'm going to do 180 times 5, which is what? 900, but what do I have to subtract? I have to subtract 360, and I would get 540, which is the angle degree. Questions?
So both of them would be the same thing.
Both of them will get you the same answer. On the table, using Tia's method, okay, I know that a triangle was 180, right? So as you fill out the table, if you notice,
I almost forgot.
you'll notice that the number of triangles in Tia's method is actually 2 minus the number of sides. All right, that should be a multiplying sign. So 4 minus 2 is 2. 5 minus 2 is 3. That's going to be the number of triangles that wind up in the actual polygon. For Cody's method, it's the same as the number of sides. So if there's 4 sides, you're multiplying by 4 triangles. If there's 5 sides, you're multiplying by 5 triangles before you subtract 360.